Hello, students. Welcome to the Global Academy. I am Shaikh sir, your chemistry educator. Today we will study the electrochemistry, one of the important topic of the 12th class or PUC second year. First, let's see what are the subdivision or the subtopics in the topic. Now, first one is electrochemical cells, galvanic cells, Nernst equation, conductance of the electrolytic solutions, electrolytic cells and electrolysis, batteries, fuel cells, and the corrosion. Before starting the topic, we have to study first two things. One is the oxidation, and then second one is the reduction. Now, what is the oxidation? Oxidation is the loss of electrons of an atom and or the molecule is called the oxidation. Loss of the electron. Now, for example, if you take the zinc, Zn solid, it oxidizes. It gives Zn2 plus 2 electron. It gives 2 electron gives. This is called as the oxidation. Now, for example, similarly, you take Ag solid gives Ag plus 1 electron, and this is also called the oxidation. The loss of the electron of an atom or ion or the molecule is called as the oxidation. Now, what is the reduction? Reduction is the gain of the electron of an atom or ion or the molecule is called as the reduction. Gain of the electron. For example, you take Cu2 plus, it takes the 2 electrons and become copper solid. Copper solid. This is the gain of the electron by the ion and hence become a copper, and this is called the reduction. This is called the reduction. Similarly, we can also write like this also. Zn2 plus it takes 2 electrons and become Zn solid, and it is also called as the reduction. So oxidation, loss of the electron, reduction, the gain of the electron. Remember, where the electrons are released, these electrons will not remain in the free phase. The space has to used up. So oxidation, if there is an oxidation, definitely there is a reduction also. So oxidation and reductions are taking place simultaneously. Now, the same thing we will study by taking some examples. So this is a figure. You can see that the figure. Two beakers are there. This is one beaker and this is the second beaker. First beaker containing the zinc sulfate solution. Zinc sulfate solution where the zinc rod is dipped. The second is the copper sulfate solution where the copper rod is dipped. And then these are the connected by the external wire. Sometimes we are using a bulb here, or sometimes we are using the ammeter to see the current. Then there is a tube like this, the bent tube you can see, and that is called as the salt bridge. Now, what is the salt bridge? I will tell you later. After some time, I will tell you later. Now, this is a setup, and this is actually a setup for the Daniell cell. The setup for the Daniell cell. It is a setup for the Daniell cell. Copper and the zinc. Zinc sulfate solution where the zinc rod is dipped. Copper sulfate solution where the copper rod is dipped. Now, when you dipped and you connect it, so what happens? The two reactions are taking place. One is the oxidation is taking place, and the another is the reduction takes place. Now, how the reactions are taking place? Let's see. Now, in the zinc electrode, zinc solid, okay, gives you the zinc 2 plus 2 electron. So this is called as the oxidation, and this is called the oxidation half reaction. Oxidation half reaction. Whatever the electron liberated, the electrons are given to the zinc rod. So zinc rod takes the electron. As it takes the electron, the concentration of the electron goes on, increases. Hence, the zinc rod will have a negative charge. Hence, it is called as the negative electrode. So you can see here, Here you can see it is a negative electrode. Okay, negative electrode. Now electrons move to the copper, move to the copper, to the copper rod. At copper rod, what happens? This copper ions, that is 2 plus, it takes these two electrons and become copper, and this is called as the reduction. This is called the reduction, where the electrons are used up or it is gained by the copper ions and become the copper, and this copper is slowly deposited on the copper rod, and you can see that the dark color, that is the deposition of the copper, and this is called as the reduction. These two are taking place simultaneously. The oxidation takes place at the zinc electrode and the reduction takes place at the copper electrode. As at the copper electrode, the electrons are used up or it is consumed, so it is called as positive electrode. It's a positive electrode. Now, due to this, the reaction, that is called as the reduction reaction, is taking place at the copper electrode and the oxidation reaction is taking place at the zinc electrode. Due to this reaction, now whatever the potential is generated here, and that potential we can see here, and this type of the setup, already as I said that it is a Daniel cell example, and this type of the cells we called the electrochemical cells. The definitions we will study later. Now generally the current which is generated here is due to the two half reactions. That is what I am writing here. Okay, already one I had written here, one more is I am writing, that is Zn solid gives Zn2 plus 2 electrons. So if you take this is cancels out. So Zn solid plus copper 2 plus gives Zn2 plus copper solid. So this is called as overall reaction, or it is called as redox reaction. And this is a redox reaction by which the potential is generated in this electrochemical cell. Now, the one more important thing is that is about the salt bridge. Now, what is the importance of the salt bridge? Now, as you know that here large number of what is called as the sulfate ions and the zinc ions are there. But what happened? The zincs, it converts, okay, into what is called as the zinc is converted into zinc ions. Now the concentration of the zinc ion goes on increases. As the concentration of the zinc ion goes on increases, the electrolyte will become positively charged. So here a positive charge is taking place, and at the other hand, here now the copper ions start depositing on the copper, the rod, and because of that reason the number of sulfate ions increases, and due to that reason the negative charge is developed in these solutions. This solutions takes the negative charge and this solution takes the positive charge. Now here the salt bridge play a very important role to neutralize the charges. I think everybody has seen that for electric connection, for any electric connection, we require two wires. One, a positive current is flowing, and another one, the negative current is flowing. Here, the negative current, the current of the flow, that is electron flow, is from zinc to the copper. That is, negative current is flowing from zinc to the copper. At the same time, the positive current is flowing in the opposite direction. And hence, because of that reason, that entire setup becomes neutralized and it gives a voltage of 1.1 volts. 1 volt the charge it develops. And this is a very good example for the electrochemical cell. Now let's see the definition. Now, what is the definition of the electrochemical cell? An electrochemical cell is defined as a device used to convert chemical energy produced in the redox reaction into the electric energy. The electrochemical cells are nothing but simple device which convert the chemical energy into the electrical energy. The device we called the electrochemical cells. Similarly, the galvanic cell, an electrochemical cell in which a spontaneous chemical reaction produce electricity, is called the voltaic cell or the galvanic cell. These are one and the same, the examples for the electrochemical cells. In such cells, the chemical energy is converted into the electrical energy. For example, the dry cell, nickel cadmium cell, lead storage cell, fuel cells are the sum of the example for the galvanic cell. Now, what is a salt bridge? Now, just we had studied, salt bridge is nothing but the U-shaped bent tube, glass tube, U-shaped bent glass tube. A galvanic cell, the solution is connected by the salt bridge. This is a U-shaped glass tube containing a concentrated solution of the inert electrolyte such as the KCl or the potassium nitrate, okay, and also sometime the silver nitrate is also using here. So strong electrolytes are using, or solidified solutions of such as the electrolyte in the gelatins and the agar and agar. So here we are using that to have what is called as the salt bridge. What are the functions of the salt bridge? Okay, sometimes they are asking, okay, the functions of the salt bridge. So there are one or two important functions of the salt bridge are there. It provides an electric connection between the two solutions and thereby completes the electric circuit. This is very important. Until unless there is no salt bridge is there is no electric current is produced. The electric current will produce only after dipping the salt bridge when the two solutions are connected. Okay, if you see the figure, when the two solutions are connected by this, then only there is a electric current is generated. Otherwise, absolutely there is no electric current is generated, and that is the first. The second is it prevents the mixing of the electrolytic solutions. It not allow the solution to mix one another. It maintains electrical neutrality in both the solutions by the flow of ions. That is what already I had told you, that the neutrality is very important. So it neutralizes the solutions because at the zinc electrode, the zinc ions will be more. At the copper electrode, the sulfate ions will be more. One will acquire the positive charge, another acquire the negative charge. So this is neutralized by the salt bridge. So these are the important functions of the salt bridge. Next comes to what is called as the electrode potential. It is defined as the tendency of an electrode to gain or lose the electrons when it is in contact with its own ion in the solution is called the electrode potential. It is a tendency to gain or lose the electrons. Hello students, are you preparing for NEET, JEE or Karnataka CET? Looking for the right guidance to achieve your dream rank? Welcome to the Global Academy live coaching classes for NEET, JEE and Karnataka CET. A single point and a complete solution for the competitive exam preparations. Specially designed for 11 and 12 classes or PUC first year and second year students, combining board syllabus with the entrance exam coaching. Our new batches starting from 25th March 2026 for the academic year 2026-27. The course fees is 9,999 now with 50% discount. Enroll for just rupees 4999 for the entire course. Limited seats are available for enquiry. Call these numbers and you can scan QR code for the easy payment. Now, how to calculate the electrode potential of a single electrode? The electrode potential of the single electrode can be determined by using the Nernst equation. By the Nernst equation. Now, let's see what is the Nernst equation. What is the Nernst equation? Now, take a general reaction. Now, general reaction is like this: A plus B gives, okay, C plus D. This is a reaction. This is the electrode reaction. We can say general electrode reactions. So, E of electrode is equal to E naught of electrode minus RT by NF ln concentration of C into concentration of D upon concentration of A upon concentration of B. Here E is the electrode potential. E naught is the standard electrode potential. Now, what is called as a standard electrode potential? Standard electrode potential is nothing but when the electrode is in contact with its own ion under the unit activity or unit concentration at 25 degrees centigrade or 298 degree Kelvin. At that time, whatever the potential that electrode gives, that potential we called the standard electrode potential. R is gas constant, T is temperature, N the number of electrons transferred in the reaction, F is Faraday, and this is, as you know, this. Now, this is a general reaction of the Nernst equation. Now, we can take one example and we can write the Nernst equation to that example. For example, I am taking this reaction. Okay. Copper 2 plus 2 electrons. Two electrons gives copper solid. Now, for this, if you write the Nernst equation, then I am writing like this, that is E of Cu2 plus 2 Cu, okay, solid. The representation, carefully see that is nothing but E naught Cu2 plus to Cu solid minus RT by NF, okay, ln concentration of copper Cu upon concentration of Cu2 plus. Okay, so this is equal to, okay, that is equal to E naught copper 2 plus copper solid minus RT by N. There are two electrons are there, two electrons, so it is a 2F ln 1 upon concentration of Cu2 plus. Because concentration of Cu is equal to unity. Whichever is in the reduction state, the concentration is taken as unity in the reaction, in this reaction. So that is a important part. Now, if we convert these all, then we can write that is the E of copper 2 plus 2 copper solid, which is equal to this representation. I will tell you in the coming classes, that is important. So that is E naught Okay, Cu 2 plus to Cu solid plus. By converting these all, then you are getting that is 0.0591 upon 2 log concentration of Cu plus. It is 2 plus. So this is what is called as the Nernst equation for this reaction. For this reaction. So similarly, we can write the Nernst equation for any of the reactions. Any of the reactions. For example, I'm taking one more, and I'll stop here. I'll take what is called as the this reaction. Zn solid gives Zn 2 plus plus 2 electrons. Zn plus 2. Okay, it's a reversible. So apply what is called as the. Now here we can see that. So this is what is representing I am here is it is Zn solid to Zn2 plus gives E naught of Zn solid to Zn2 plus minus 0.0591 upon 2 log Zn2 plus. Now, the copper I think if you remember, then I had represented like this for the previous example. I had represented like this, that is E is Cu2 plus and Cu solid. And here you can see that here and here. See that. What is the difference? What is the difference? Just see the difference in this. Okay. See the difference. So here I had written this. I had it in this way. I had it. And this is called as the oxidation potential. Oxidation, because here you can see the zinc to zinc ion, this reaction, this is the oxidation. This is the oxidation is taking place, and I had written for this representation. And this representation shows that the reaction which is taking place is the oxidation, and the potential what you are getting is called as the oxidation potential. Here, if you see this representation, this is a reduction potential. Reduction potential, which is this here representation, that is the reaction what I had written is like this: copper 2 plus plus 2 electron gives copper solid. Here the electrons are consumed or used up. Okay, it's become, and hence it is a reduction. And when we are writing for the reduction, this is a main difference. This is the main difference representation. Nobody expressed in terms of words. It is expressed in terms of what is called as notations, representation. That representation is play a very important role in this electrochemistry part. I'll stop you.